And so that's the SIR stands for standardized incidence ratio, which is the ratio of the observed to expected. It was a statistically significant increase in 2 of the block groups, and block groups 2 and 3 are right here, and they're both located in fairly close proximity to the towers. Now, we don't know exactly where these homes were because that information was not part of this analysis. The health department decided to further evaluate this by looking at the specific location, looking at the visibility, looking at the cases, basically doing a case analysis. And so they looked at the tumor type and looked at a variety of other things that might explain why these individuals had brain cancer other than exposure to towers at Lookout Mountain. And this is a standard approach to see if there's other factors that might explain it. There were differences in the block group and the types of tumors that were identified in each block group. I mentioned that other types of cancer that have been previously associated with RF were not elevated. And so there was some inconsistency, I should say, in what you might expect to find. But they did find an increase in these in CNS tumors in these 2 block groups. So looking at individual cases, they found that 100% of the cases had a direct line of sight, at least to some of the towers. So this is important because RF is propagated in a line of sight type of fashion. And so if they were to be exposed, they would have to be able to see the transmitters. They also looked at duration of residence as a potential explanatory factor. So in block group 2, all of the cases had lived in that area for greater than 10 years. So this is sufficient time for a tumor to develop. It's a reasonable latency for someone to develop a tumor. In block group 3, 3 of the 5 cases that were identified had lived in that area for less than 5 years. So this is less of evidence that perhaps the towers were eliciting this type of effect. So, there's a number of issues associated with this type of result. These types of studies where they looked at observed divided by the expected number of cases, they're meant to be done, they're what we call screening level analysis. They can be easily implemented. They don't cost a lot of money. They give us an idea of whether or not there's sufficient evidence to continue looking at the issue. And there are some difficulties in interpreting these types of results. So I just want to point out some of the issues. Statistical power is one of them. There are not that many cases identified. So there were 5 cancers in that one block group and 5 in the other block group. That is not a lot of statistical power to detect a difference, even if there is one. Other factors can explain the outcome. Typically, in a brain cancer study, you would want to see hundreds of cases in order to have a statistically robust sample. Clustering. There's issues associated with clustering in time and in space. So here we see clustering in the block groups closest to the towers. So that gives us some indication that perhaps the towers were might be implicated as a causative agent. Temporal clustering is also an issue that was considered, but given the time span that transmitters were brought online on Lookout Mountain, temporal clustering is really not something that might explain the outcome. Consistency. I mentioned that in block group 2, the tumors were different than in block group 3. In block group 2 was primarily women, in block group 3 was primarily men. So this is not giving us a lot of consistency. These are sort of inconsistent results. And if there were a true effect, we might expect to see more consistency between the actual subtypes of brain cancer and the actual gender of the individuals who develop cancer. Then again, we only had a few cases. And so you have to sort of look at these limitations and and make judgment decisions about what cause-effect relationship might be present. So it was one of the things that do lend more consistency is that brain cancer were the two types of was the cancer that was elevated in both block groups. Other issues, migration. Migration is a big problem, and I'm talking about people migrating in or out of the study area. So if you have a lot of people coming in and they're just moving into the community and they've never been exposed to the towers, then you wouldn't expect them to be at risk, to have an increased risk if there was a relationship. But more importantly, if you had somebody who lived there all their life and they decide to move away because for whatever reason, and let's say they move to another state, and then right after they move in, then all of a sudden they're diagnosed with a tumor. So that person would not be counted. And so that would have contributed to a reduction in the risk. And even if there was an association, you would not be able to include that individual in the study. And I've heard anecdotal reports of people moving away and then later on they're diagnosed. So this is just something that adds to the uncertainty of the study. Confounding. Confounding is when one factor explains the relationship and it's related to the exposure that you're interested in. So in this case, socioeconomic status was well controlled for. Age was also controlled. They adjusted for these things when they did their expected number of cases. Occupation is another thing that might explain the findings. If every one of these brain cancer cases had some job that was associated with brain cancer, then they just happened to live on Lookout Mountain, then it might have been the occupation of these individuals that explained their brain tumor rather than the exposure to the towers. That could be one explanation. Another explanation is that the combined effect of having a job and living on Lookout Mountain could have put them over the hump, so to speak, in terms of attaining a threshold for developing a tumor. So that's another potential explanation. There's no right and wrong here. I'm just giving all the strengths and limitations of this type of design. And then there's exposure. They looked at block groups and not individuals. There's shadow effect. So if somebody lives on the back side of a mountain, they can't see the towers, then they're probably not likely to be exposed. In this case, they did go back and on an individual level of the cases, they found that all the cases had direct visibility with the towers. So that is something that would strengthen the potential association here. So the bottom line is, this is a useful type of exercise to get an indication of whether or not there is a potential problem associated with exposure to the towers in this community. It's not a definitive study. It's not going to prove that the towers cause cancer, but it does give an indication of whether or not you might want to do further analysis. In this case, there was enough evidence, at least with brain cancer, to suggest that maybe more research is needed. So, it was in 2003, I believe, is when we initiated this study that was funded by the National Institute for Environmental Health Sciences to characterize RF exposures and to evaluate biological markers among Lookout Mountain residents that live within about 5 to 6 kilometers of the main group of radio and TV transmitters. So why did we look at biomarkers? There's not enough cancer cases to really do a definitive study. These are more results. This slide basically just shows that if you categorize people in terms of distance, elevation, or how visible their home was, how visible the antennas were from their homes, you see an increase in RF, no matter whether you're measuring interior or exterior levels.